next speaker is Chris Markiewicz. He is coming to us from Stanford University. Oh. Okay. His background is in computer science and functional neuroimaging analysis. During grad school, he began contributing to neuroimaging Python projects and using GitAnnex to manage his data and documents. Since 2019, he has been involved in the Open Neuro project, which is a data repository built on GitAnnex and datasets. And today, he'll be giving us a talk on maintaining large data sets at scale. Please welcome Chris.
Thank you. That's the direction. Okay. Nope, that came back to the wrong screen. Okay, that's better. And of course, now that's on the wrong screen. Can I try this again? Happy. Okay, great. Thanks for having me. Again, I'm Chris Markiewicz. I'm going to be talking, and I'm associated with the Open Neuro project at Stanford. So Open Neuro, you've been mentioned a couple times today. It is an open repository for neuroimaging data that is organized in the BIDS format, which you also just heard some about, so I won't go into that any further. Currently, we have about 1,500 public data sets, another 1,300 or so private, mostly people just kind of playing around with the system. So I wouldn't take too much or worry too much about that. But that's about 65,000 participants. And so and this is all dominated by small data sets. As opposed to these large consortium efforts. All right, so this is what a data set looks like. It's a versioned object. And so you can see the versions, they're citable objects, and you can browse you can browse inside here. And it is harder to do this while looking in that direction. All right, so when that loads from S3, you'll see. So that's what the website looks like. And what are we actually, you can click here. Wait, really? There we are. Okay, so our goals are we want high availability and we want data integrity. And to a large extent, we want to be out of the way. So as I didn't mention, but now I'm going to mention. So files are published to S3 using export trees, so you can fetch them directly from S3 without knowing anything about GitAnnex datalad. But they're also mirrored to GitHub, and versions are just lightweight tags. So if you are using GitAnnex, you can go back in history, you can fetch older versions of files. And there's, for the most part, no need to hit Open Neuro servers. So we can focus on managing the data and not on, and for the most part, we don't have to maintain a high availability service ourselves. The next thing is obviously is data integrity. If you fetch it, you want to be able to trust it. So a lot of that is just built into GitAnnex. So we're routinely running GitAnnex FISC. We have cold storage backups. The other thing about these public mirrors is that adds a certain amount of transparency. So anybody can fork this, and they don't have to trust that we aren't going to mess with it, because it will be completely obvious the next time you do a git fetch that the history has been tampered with. So what sorts of problems do we run into? So with over 2,500 total data sets, these are supplied by users. They've been managed by an evolving code base over about 8 years. And so problems do come up, and we may not find out about them for a bit. So the main way we found to detect problems is actually just to check the GitHub mirror. So when you create a new snapshot, it tries to get a DOI. If it gets the DOI, it builds the snapshot, creates the tag, pushes it to S3, and then finally pushes or syncs to GitHub. So if anything in that process fails, it basically can show up as a failure here. So we have a script, basically just wraps git ls remote to check, and our GraphQL interface. Cool. I'll try to speed up. And yeah, so those are the sorts of problems you can see. So what sorts do we see? So file corruption in transit. That was one of the biggest ones. When we get it and we hash it, there's nothing that tells us that it's what you sent us. So we've moved we moved the hashing into the command line client that's written in JavaScript. So that's we actually create the commits and push using the Git interface. So we push both the Git annex and the Git commits to the main and Git annex branches. Another thing that can happen is files can become unannexed, mostly because people try to upload too quickly and something gets out of sync. Short story is you can replay all the commits using something like this. Scripts are up there. I'm not going to go through them in any more detail. Then for more general things is older data sets have unversioned S3 remotes. We need to clear them out, recreate them, and exports can be interrupted. One thing I did want to share is we have large data sets. So some of them are, I think the largest we have is around 8 terabytes. That's often more space than we have. So if we want to modify the history and we want to make a backup, one, it takes a lot of time. Sometimes it takes more space than we have. So but one thing Git clone and rsync can let you do is do make a full clone in about 20 seconds. Or a full mirror in about 20 seconds. And that's, like, this is the additional, if you run du, so this data set was 2.1 terabytes, but it only takes 570 megabytes in order to have a complete clone that diff-rs with nothing. So that I thought was something people here might be interested in. Thanks.
Okay, thank you very much. If there are any questions, we'll take 1 to 2 questions from the audience. Yep.
So you talked about an incomplete export and having to detect that, but can't you just resume the export and have it fixed up?
Yes.
Okay.
That actually was that.
Thank you. It just went so fast I
Just
couldn't read it.
re-export,
Thank
and
you.
then, yeah.
Good. Anyone else? Yep, right here.
So on the last slide, you mentioned something gets smaller, but I didn't catch it.
Oh, so
How do you make it smaller in that case? You rsync something?
So basically, if you get cloned on a local file system, it uses hard links where it can and then copies where it can't. But that ignores the annex altogether. So rather than, so the second rsync command, or the first rsync command there, essentially just pulls in all the annexed files as hard links. And then the last one cleans up any mismatches.
Okay.
Okay. Good. Thank you very much.
Thank you.